Let's take a look at this first review question. Number 1, the 5,000 billion electrons in a penny repel one another. How come they don't fly out of a penny? So, true or false? Pennies have electrical charges in there. Answer is true. Everything has charges, right? Everything is made out of protons, neutrons, electrons, quarks, leptons, all that good stuff. Okay? So how come if there's 5,000 billion electrons inside a penny, when you grab a penny, you're not getting shocked there? Why not? Because if there's 5,000 billion electrons, there should also be, yeah, Brett. Protons, exactly. Okay? Therefore, the electrons will be neutralized. The net charge will be 0 by just as many positive charges, 5,000 billion protons. So there's no net charge. And then also, what's the rule of thumb? Opposites will what? Attract, and like charges will repel. So literally, everything in nature is glued together, not with super glue, right? But electrically glued together. So there's an old saying that a picture is worth a what? 1,000 words. So you can, answer these with short sketches and pictures and phrases, right? So the idea is, if you have all these electrons inside the penny, these orbital electrons, they should repel each other, but it's actually electrically neutral, right? So before we had the newer planetary model, and now we have the cloud model of orbitals and stuff, there was this British scientist named J.J. Thomson. He called it the plum pudding model or whatever, right? But the basic idea is your elementary school science, right? You have a positively charged nucleus with a negative orbital electron. But really, this is out of date, right? It's all clouds that you learn in chemistry class. But the basic idea is the protons, the positively charged nucleus, keeps the orbital electrons from flying out. Okay? How about number 2? This is kind of sad here. 200 years ago, there were these young boys called powder monkeys. That's not a good job. That would qualify for a dirty job there. Okay? Carrying sacks of gunpowder to refuel or resupply cannons of warships. Then there was a law that they had to do it barefoot. Why do you think that was? Okay? So if you think about it, if you're a poor kid and you're running around and your job is to bring sacks of gunpowder, bomber, there we go, around there, right? What might happen as you walk around here, around the ship there, right? So if you got these big old boots on, right, and let's say you walk across the captain's quarters with a nice shaggy wool carpet, what do you guys remember? What might happen? You might build up a lot of what? Yeah, exactly, I'm hearing it, okay? You can accumulate a lot of charge, right? So let's say rubber soles like to grab electrons, right? Shaggy wool carpet likes to lose electrons. And eventually, if enough charge builds up, what? Boom, right? You get that giant static discharge there, right? So unfortunately, probably what happened is some poor kid, boom, like, whoopsies, we just blew up a powder monkey. That's not good. So luckily, somebody in the British Empire had enough foresight and scientific understanding to make it a law. You got to do it barefoot, okay? So why is that? Why would taking off shoes and socks help? Because that way, any charge you accumulate will simply what? Dissipate to the ground, exactly, okay? Where this, oopsies, there you go. This lady's trying to buy some gas here, and she's doing nothing wrong other than getting in her car, and she's got a fleecy, like, whatever sweater on there, right? So unfortunately, in this lady's case, too much charge builds up on her body, and so what's her one mistake? I mean, you shouldn't get out of the car, but that's okay. Yeah, touch something metal, ground yourself, but don't touch it by the fuel tank. So of course, it's kind of natural to try to reach by the fuel tank, and boom, okay? So she got lucky, the whole tank didn't ignite and catch on fire and get burns. But unfortunately, every so often, somebody dies from this, so it's not cool, okay? So what she should have done is she should have not tried to put out the fire. Just there's a fuel shut-off, and then just run. Because if your car blows up, it's bad, but insurance will cover it, okay? Got it? So this is a real risk there, where you always got to put a container on the ground when you're refilling a portable container, and also not to charge up your body there, right? You guys remember what airplanes do? There's a little wire, right? There's a grounding wire. There we go. That they attach so that you don't build up that charge there. Okay? Got it? So again, a picture's worth of what? 1,000 words, okay? So go ahead and, answer the short phrases and all that. You guys want to do one more? And then set you loose? Okay? How about this? Ben Franklin invented a device which would alert you if lightning struck. Explain how this would work here, okay? So all it is it's 2 bells. One bell would be on top of like a church steeple with a lightning rod up to the sky, and one would be a bell with a wire to the ground. So you tell me, why would this be a nice way to help warn people of an imminent lightning strike here? Okay? So So if you think about it, I'm going to try to demonstrate this with the little static fly stick here. Passes overhead there, right? Let's say it has a lot of electrons, like this little stick generates charge here, right? Then what might happen is it'll induce an opposite charge in that little metal neutral ball there, right? So it'll first then attract this thing there, and then why does this thing fly up in the air then? Because it grabbed electrons from what? The rod here, right? And then what do you know about like charges? They will repel there, right? So then, since it's being repelled, that neutral ball then is going to start to fly towards the grounded bell. And then once it hits the grounded bell, it's going to lose its charge, and then the process will repeat itself. So if you recall, if I can get my timing right here, I can actually get this thing, there we go, to dance from the stick to my hand back and forth. Ah, there you go. Because it first gets charged up, repelled, then it hits my body, and then gets grounded. Okay? So then eventually, if you had this Ben Franklin lightning system, if you hear the bells ringing, then you want to take cover because you're about to get a lightning strike. Ah, there we go. Okay? And again, why do I keep grabbing the sink? Because I'm mental? Probably. But what am I doing? I'm just trying to get rid of, I'm grounding myself, the excess electrical charge there. Okay? So I don't mess up my computer. Which I did one year, and I had to reboot. That was really annoying. There you go. Okay? So, for the